We now want to extend our use of continuity by looking at the different properties of continuity so we can find shortcuts to determine if a function is in fact continuous. If we start with a constant b, some real number, we have two functions f and g, and both of these are going to be continuous at our x value equal to c. We also know all of the following are to be continuous. We can multiply the constant times a function. We can add or subtract f and g, the function values. We can take the product by multiplying f and g. We can take the quotient, dividing f by g, with the proviso that the g value does not equal 0. Also, if we consider composition of functions, if f is continuous at g of c, then we also have the composition of f of g as continuous. Let's look at a specific example. If we have f of x equal to 5 over x minus 1 and g of x equals x to the fourth, first thing we want to do is determine f of g of x. Remember, we start on the inside. We take f of, and g of x is replaced by x to the fourth. We take our f equation, replace the x value with x to the fourth, so we wind up with 5 divided by x to the fourth minus 1. So this is our resulting composition function. We want to find the values of x for which this composition is discontinuous. So where do we look? We're concerned about when the domain is not defined, so we look at the denominator, x to the fourth minus 1. That is not allowed to equal 0. We can factor this as x squared minus 1 and x squared plus 1. That can't equal 0. This never equals 0. However, x squared minus 1 equals 0 if we factor this again. So we have x cannot equal 1 and negative 1. These are going to be the problem areas that we have because of this function where the function is not continuous. Let's look at a graph. If we have a table of values of x is 0, y has a value of negative 5. If x has a value of 1, we have a vertical asymptote. If x has a value of 2, by substituting 2 into this equation, 5 over 2 to the fourth minus 1, we simplify that to be 1/3. And if we put 3 in, we get 1/16. So our graph looks about like this. If we take x equal to negative 1, we have another vertical asymptote. X equal to negative 2 gives us 1/3. X equal to negative 3 is 1/16. So once again, we wind up with a graph that looks like this. And to complete the region from x equal to negative 1 to positive 1, we have this. So in this particular case, our points of discontinuity would be the x value, x not equal to 1 and not equal to negative 1.